Hello, welcome back student to design and analysis of algorithm subject. This is common for the CSE and the IT 6th sem students. Before going to the today's lecture, we are going to see what we have completed in the previous lecture. In the previous lecture, we saw the graph coloring. Okay, this is graph coloring. The two adjacent nodes should not have the same color, and I gave you the example. I shown you related to the map. I took the phi state and I gave the different colors to that. If you did not watch that video, go and watch the previous video. Okay, and today we are going to see the n-queen problem. This is a most famous problem in the backtracking. Okay, n-queen problem is like we have the 4-queen problem, 8-queen problem. Okay, like we can say, if you know the chessboard. Okay, if you know the chessboard, then this problem can be easy for you, how the queen will move in the chessboard. So like we will have 4 by 4 means 4 queen means 4 by 4. Okay, 1, 2, 3. So like this 4 by 4 crossboard. Okay, so the n-queen problem means if you have any number of queens and if you want to place in the n by n matrix, that also possible. How we will see. N-queen problem of placing n chess queen on n by n. Okay, here n by n chessboard, so that no two queens attack each other. No two queens attack each other. They should not be adjacent to any one of the queen. Okay, then this problem who solve Naive algorithm generate all possible configurations of queens on board and print a configuration that satisfy the given constraint. So as we discussed when we study about the backtracking, backtracking is a purely based on the constraint. It should be follow all the constraint and give the output. Okay, so we need to follow all the constraint related to the n-queen problem and we need to give the result. Okay, and that will be possible with the help of naive algorithm. So what are the constraint, or we can say rules? The first one is no two queens in the same column. Okay, no two queens in the same column. Second is no two queens in the same row. So you should not have the two queens in the same row and you should not have the two queens in the same column. And the last one is no two queens in the diagonal. Okay, so that is whenever you are placing the queens in the 4 by 4 matrix, example 1, 2, 3. Okay, so here if you are placing the q1 queen 1 in the first column, the rest of the queens you cannot place in the same column, as well as you cannot place in the same row. I will change the color, then it will be easy for you to understand. So here this is in this row I cannot place any one of the queen and I cannot place in the same row of the queen 1 and as well as the diagonal. In these three possibilities are there, we need to follow this constraint and we need to complete the problem. Okay, the rest of the boxes like this, this, these six boxes I can fill any one of the queen. Okay, once I fill the q2 here example, okay, so I cannot place here, I cannot place in the same column, I cannot place in the same row. So only the thing is 1 2 is left. So I cannot place here also, this is a diagonal and this is a diagonal. Okay, so only the left is this, so I don't have any possibilities in row 3. So like this we need to find all the possible solutions, for the backtracking. Like as a backtracking we need to check all the possible solution of the given problem. Where we done in the dynamic programming, in the dynamic programming we are looking for the optimal solution, but in the backtracking we are finding all possible solutions, whatever the possible solutions are there for the given problem. Okay, let's take the example and we'll see. Okay, and here here we have the 4 by 4 matrix chessboard and we need to place the queen and we need to follow the rule constraint. What is the constraint? First, no, not in same row, not in same row, not in same column. Okay, not in diagonal. Okay, not in diagonal. So here, before going to, first I am neglecting this because for your understanding purpose I am removing this constraint. We will add later, but first we will focus on the same row and the same column. Okay, we can add this also, but for drawing the state space tree, SST, state space tree, state space tree. And what backtracking is doing? Backtracking is doing brute force attack. Okay, it is brute force attack is applying on this problem and it's getting the answer. Okay, so let's take the first one, draw the state space tree. First, okay, and here if I place the queen here, I will change the color, q1. If I place the queen 1 here, okay, so here state space tree is x is equals to 1. What is this? This is column, so I cannot place in the same column. Okay, I cannot place another queen in the same column. Okay, the next, here is 2, here the queen 1, okay, and here queen 2. So here we place the queen 1 as the same. I can place, if we remove, if we just concentrate on the same row and the same column, so I cannot place here and I cannot place in this column also. So I can place here q2. Okay, so here x1, x2 is equals to 2. Okay, so here it is placed in the second column. In the same way, I can place in the third column third queen, and I can place fourth queen in the fourth place, in the fourth column. Okay, so here q3 and q4, whatever we have drawn here, x1 means in the first column, in the second column, in the third column, in the fourth column. Okay, these two are not violating. Can you see? Not in the same row, not in the same column, but it is in the diagonal. So we need to check this also. So what is the main purpose of the backtracking is, like when you fill, then if anything is problem, if your constraint is not satisfying, at that time we can go back and you can change. So here for the diagonal, in the last, when I reach in the last, so can I see, is there any possibility for the queen 4 to move at the right and the left? No, because in the same column q1, q2, q3, now we don't have any column. So we will go up, go back, and here in the queen 3, is there any possibility to keep the q3? Yes, you can move q3 in the column 4. So here q3 in the column 4. Okay, this is 4 and this is 3. Okay, what is it? Here queen 3 in the column 4 now, sorry, queen 3 in the column 4, and here there is no possibility here. Okay, here in the queen 4 in the third column. Okay, okay, so now here we place q4 and q3, but here again we don't have a possibilities for queen 4. Can I place here? No, I cannot play the rest, so I need to remove this. Then after that, can I place here on the right hand side? There is no possibility. Okay, so for that, here, one second. Okay, so here, can I place q2 in the right hand side? Yes, now here I have a possibilities. Now here I have a possibility. So what I can do here, I can go queen 3, sorry, queen 2 in the column 3. Okay, here queen 2 in column 3, in column 3. And what are the other possibilities? I can place queen 3 here and I can place queen 4. No violating the rule, this not in the same row, not in the same column. Okay, we will see this. So this is here. So the next is 2 4. Okay, what is here? This will be in the 2 and this will be in the fourth column. Okay, first queen, second queen, third queen, fourth queen. First queen in the first columns, second queen in the third column, third queen in the second column, fourth queen in the fourth column. Okay, now in the diagonal, it is there any more possibility for the q4 to the move the right hand side? We don't have. But can I move this to here? No, in the same column. If I move q3 in the last column and q4 in the second column, there is one more possibility. Here 4 and here 2. Okay, so here I need to erase and I need to check q3 and q4. Okay, so this is the possibility. Okay, now can I move in the right hand side? No. Can I move? No, because in the same column. Can I move this q3 in the right hand side? We don't have any place. So what we need to do? Again we need to remove, then we need to remove. There is a possibility of q2 to move on the right hand side. q q2. Okay, and first second queen in the fourth column. Okay, second queen in the fourth column. Next is, where is the other possibilities for the next two queens? The next two queens you can place here q3, q4, not in the same column, not in the same row. So here third queen in the second column and fourth queen in the third column. Okay, fourth queen in the third column. If I remove this, okay, if I change the diagonal, like here it will be q3 and here q4. Okay, not in the same row, not in the same column, but it is a diagonal. We'll see that. I am just showing you how the backtracking is working, and we need to see what is backtracking actually, because it is reaching the last and it is coming back in the backtracking, checking all the possible solutions. Okay, so here now can I move with the right hand side? No. Can I move in the right hand side? No, because in the same column. q3, can I move in the right hand side? No, it is the same column. q2, can I move in the right hand side? There is no place here. So what we need to do? We need to do the backtracking again and move the q2, q1 in the column 2. Okay, now so let's see here, this one q1 in the second column. Okay, where it is? In the second column. Next, after this, where is the possibilities now? I can place in the one. Okay, here I am placing q2 because not in the same column. q3, q4. Okay, so draw this second queen in the first column. Okay, second queen in the first column. Then from the first, okay, when we have the first, from 1, queen 3 in the third column and queen 4 is in the fourth column. Okay, next, move. Can I move this to here? Okay, yes. So like this you need to move. Sorry, here can we move q2, q4 here? No, we don't have any possibility. Can I move q3 in the right hand side? Yes, there is a possibility. So here q3 in the fourth column, q4 in the third column. Okay, we are going back here, fourth column, and here in the third column, fourth queen. Okay, now we don't have any possibility, so we are moving. Next, so here q1 is here, so I can place q2 here, and here I can place in the first column q3, and I can place in the column 4 the fourth queen. just we are checking, once again I am telling, just we are checking only these two conditions, two constraint, two rules. We are not checking diagonal right now, okay? Otherwise this will be the violating rule. Okay, now where is the column queen 2 now? Queen 2 in the third column, queen 2 in the third column, and from there queen 3 in the first column, okay, in the first column, and queen 4 in the fourth column. Okay, next in the same way there is a possibility is fourth column and the first column. Okay, like fourth column for the third one, this q4 and q4, and here q3, sorry, q3 q4, q3 and q4. Okay, this is also we have done 4 1, third queen in the fourth column and fourth queen in the first column. Then is there any possibility to move in the right hand side here? No, because in the same column. Okay, no possibilities. q3, is there any possibility? No. q2, is there any possibility? Yes, one possibility is here. So now move that q2. When you have a q2 in the fourth column, okay, that is fourth column, then I can place q3 in the first column and q4 in the third column. Okay, let's check it out. Here after this 4, 3 is in the first column, and fourth in the third column. So you can check here when we see this. Okay, now check 1 2 3, this all possibilities are here. Okay, now when we check all, like see this q I cannot place here, okay, and I should not place in this, and I should not place here. So this q1 is satisfying all the rule, not in the same row, not in the same column, not in the diagonal. Okay, let's check it out. The q2, 1 here, q2, yes. Okay, for the q2, no diagonal, no, not in the same column. Okay, this q2 is also is satisfying all the rule. Okay, next is q3. Just check it, not in the same row, not in the same column, not in the diagonal. Yes, no one is attacking each other. Okay, no one is attacking each other. So this is also okay, fine. Now check the fourth one, fourth queen. This is diagonal, no queens are attacking, no rows, no columns. Very good. So this is our perfect solution. So what is the solution here? What is the solution? Solution is, sorry, here 1 2 3. So what is the first one? In the second column, I will give the answer in the different color. First queen in the second column, second queen in the fourth column, and third coin in the first column and fourth coin in the third column. So what is our answer now? 2413. Okay, 2413. So this is a one possibility. Okay, when we are checking this, when we are checking after doing so many things, we got the answer this one. Okay, this one. This is our answer, but unnecessary we are doing this all the operations. Okay, we are not getting this answer, but here we are doing all the operations. So that also we will see. Okay, and what is the another answer for this? What is the another answer for this? Whenever we will get in the n queen, we will have a mirror image. So mirror image is, what is this? 2413. So when we have the mirror image, then we will get the answer 3142. Okay, this is a answer. Okay, this is the answer. Two answers we will get when we apply the queen. Okay, so first one is this, next one is 3 here, 3 1 3 1 4 2. This will be the answer. Okay, let's check it out here. See, these two possibilities are there. This is 1 2 3 4, 1 2 3 4. So what is the column number here? 2 4 1 3. First answer. Next answer is 3 1 4 2. Okay, reverse. So this is a expected output. But here, when we are coming here, can you see this is a more big hectic problem? So here, whenever, now we will check all three possibilities when we are applying here. Okay, when we are applying here. So I will erase this. Okay, now I need to follow all these three, then we will apply the state space tree. I am drawing the state space tree here first, and here when I am placing the queen 1 in the column 1, queen 1, okay, in the column 1, fine. So here next is column 2. Can I place here? X is equals to 2. Now column 2, can I place here Q2? No, I cannot place. This is violating the rule. So I cannot place here, so I will stop here. I will not go further. Okay, so I will erase this now. There is no possibilities of keeping there. Next, I will go back and I will check here. 3. Queen 2 in the column 3. Yes, there is a possibilities. Queen 2 in the column 3, not in the same row, not in the same column, not in the diagonal. Okay, now I can go further. If I have Q2 here, can I place Q3 here? No. Diagonal. Can I place here? No. Column. And here is diagonal. And if I place here, the queen 1 is a column I cannot add here. So this is also, I need to stop here. Okay, I need to stop here. After anywhere, if you go anywhere, then it will be stop here. If you go to 2, 3, 4, anywhere, we need to stop. Now here Q3, sorry, in the fourth column, can I place this Q2, can I place in the queen fourth column? Yes, we can place in the fourth column. Sorry, queen 2. Okay, so here when we place the queen 2 in the fourth column, is there any possibility for the queen 3? Yes, this is a possibility. I can place here, I can place queen 3 in the second column. Okay, queen 3 in the second column. Sorry, queen 3 in the second column. Okay, now can I place queen 4 in any one of the column? No, in the one column is queen 1, 2 column is a queen 3, and queen column 3 we can add the fourth one, but it is diagonal to queen 3. So this is also, we need to stop here. Okay, and now we will go to backtracking, and here queen 3 we need to remove. Is there any possibility to queen 3 to move here on the right hand side? We don't have any possibilities. When we move the queen 3 in the third column, then it will be diagonal to the queen 2. So this is not possible to move the queen 3. So we need to remove the queen 2 and queen 1. Then again we need to go back from queen 2. We need to place queen 1 in the column 2 first. Then next is, can I place queen 2 in the first column? No, we cannot. In the first column we cannot add, and queen 2 in the third column, that is also not possible. Queen 2 in the fourth column, this is possibilities. Fourth one, this is possible. Okay, when we place the queen 2, sorry, this is queen 1. Okay, this is queen 1, this is queen 2. Yes, this is possibility. It is not violating any one of the rule. Next, if queen 2 in the fourth column, can I place queen 3 in the first column? Queen 3 in the first column, yes, I can. Queen 3 in the first column. The next is fourth one, can I place queen 4 in the third column? Yes, I can place in the fourth column queen 4. Okay, so here we got the answer with minimum number of steps. What is the answer? 2, 4, 1, 3. This is 3, sorry. This is 3. Okay, here 2, 4, 1, 3. This is the answer what we got here, but in the minimum number of steps. But here it's taking too much time, means we need to do all the things and we will get the answer. But when we stop, when we apply the bonding function here, when we stopped here, then it will stop, and whatever the correct solution we have, we will get here. Okay, so this is about the n-queen problem. In the n-queen problem, we have done the 4x4 4x4 chessboard. Okay, and we draw the state space tree and we solve the problem. What will be the answer for the 8 queen? The 8 queen answer is, if we solve the 8 queen problem with the same method, then we will get the answer is 4, 6, 8, 2, 7, 1, 3 and 5. Okay, 4 6 8 2 7 1 3 5. This is the answer. And what is another answer for this? The mirror image: 5 3 1 7 2 8 6 4. This is a mirror image of that answer. So we will get the two possible answers after solving all the 8 queen problem. Even though if you have n by n matrix also, you can solve with the same method what we have done is the help of 4 by 4 queen matrix. Okay, for understanding we have taken the 4 by 4 matrix. In the exam maybe there will be a possibility to come 8 queen problem. Okay, that you need to solve the method how I solve here. Take the note, okay, and apply the bonding function or without bonding function is up to you. If you solve like this, no problem, or if you solve while applying the bonding function, there is no use. After applying this 3 constraint, no, not in same row, not in same column, not in diagonal. The queen should not be in the same row, same column and same diagonal. So this is a perfect answer. Okay, so this is a final. Okay, so what we have done today, 4 queen problem we saw, an 8 queen solution, and n queen problem is all about this 4 8 16, okay, 32. Like this we will have a problems. So thank you very much. We will see you in the next class with another topic of the backtracking or branch and bound. Okay, thank you very much. We'll see you in the next class.